Hello everyone, my name is K. Rajesh. I am from CSC B section. Today's my topic is about parse tree with example. Introduction. Parse tree is a graphical representation of symbol. The symbol can be terminal or non-terminal. In parsing, the string is derived using the start symbol. The root of the parse tree is the start symbol. It is the graphical representation of symbol that can be terminal or non-terminal. Parse tree follows the procedure of operations. The deepest subtree traverses first, so the operation in the parent node has less procedure over the operator in the subtree. Parse. It means to resolve a sentence into its component parts and describe their synthetic roles of or simply it is an act of parsing a string or a text tree. A tree may be a widely used abstract data type that stimulates a hierarchical tree structure with a root value and subtree of youngsters with the parent node represented as the group of linked nodes. Parse tree. Parse tree is the hierarchical representation of terminal or non-terminal. This symbol represents the derivation of the grammar to yield input strings. In parsing, the string springs using the beginning symbol. The starting symbol of the grammar must be used as a root of the parse tree. Leaves of the parse tree represents terminal. Each interior node represents productions of grammars. Rules to draw a parse tree. All leaf nodes have to be terminal. All interior nodes have to be non-terminal. In order traversals gives original input strings. Production rule. For example, t is equal to t plus t slash t into t. Then t is equal to a or b or c. Input are a into b plus c. Step 1. Here is a step 1 and step 2. Here step 3, step 4 and step 5 shows the diagram of the parse tree. Uses of parse tree. It helps in making syntax analyzing by reflecting the syntax of the input language. It uses an in-memory representation of the input with a structure that conforms to the grammar. The advantages of using parse tree rather than schematic actions, you will make multiple passes over the information without having the rephrase. The sequence of substitutions used to obtain a string using the CFG is called a derivation and may be represented by the tree called a derivation tree or a parse tree. Or a derivation tree or parse tree is an ordered rooted tree that graphically represents the schematic information of a string derived from the context-free grammar. Root label is equal to start node. Each interior label is equal to variable. Each parent or children relation is equal to derivation step. Each leaf label is equal to terminal or epsilon. The leaves of the parse tree must, when read left to right, are called the yield of the tree. Here is the diagram showing the derivation tree. Sequential form and partial derivation tree. A partial derivation tree is a subtree of a parse tree such that either all its children are in the subtree or none of them are in the subtree. Here is the example showing the sentential form. For example, x tends to a, s, b or epsilon, then then s tends to a, s, b and tends to a, s, b, b tends to a, s, s, b, b, b are the sentential forms, and the sentence is a and b, b, b. Derivation or yield of a tree. The derivation or the yield of a parse tree is the final string obtained by concatenating the labels of of the leaves of the tree from left to right, ignoring the nulls. Here is the example of derivation or yield of a tree. For example, s tends to ss or asb or epsilon, Now we require the string W is equal to AB, AA and BB. Then S tends to SS is the string. Then S can be written as ASB. Then we get ASBS, and S can be written as epsilon. Then we can write it as ABS. Then and again S can be written as ASB. Then ABASB. Then S can be written as SS. Then we can write ABAASBB, and S can be written as epsilon. Then we get ABAABB. Here is the graph showing the derivation or yield of a tree. Leftmost and rightmost derivation. A derivation is basically a sequence of production rules in order to get the input strings. During derivation, we may have many choices to replace the non-terminal in the body. Leftmost derivation. Choose first x from left side, x tends to x into x. Rightmost derivation. Choose first x from right side, x tends to x into x. To decide which non-terminal to be replaced with the production rule, we can have two options. Leftmost derivation. Choose the leftmost non-terminal to expand. Rightmost derivation. Choose the right rightmost non-terminal to expand. Graphical representation of a derivation. Filters out. Choose regarding replacement order. Routed by the start symbol S. Interior nodes represent non-terminal in S. Leaf nodes are non-terminals in T or epsilon. Node A can have children x1, x2, so on xn. If a rule A tends to x1, x2, so on xn exists. Ambiguity. A grammar is said to be ambiguous if there exists more than one leftmost derivation of or more than one rightmost derivation or more than one parse tree for the given input string. If the grammar is not ambiguous, then it is called unambiguous. A grammar is said to be ambiguous if it permits to terminal string to have more than one parse tree, that is, more than one leftmost derivation or more than one rightmost derivation from the same string. If the grammar is not ambiguous, then it is called unambiguous. Removal of unit production. Any production rule in the form A tends to B, where A, B non-terminals is called unit production. Removal procedures. Step 1. To remove A tends to B, add production A tends to X to the grammar rule whenever B tends to X occurs in the grammar. Therefore, X terminal X can be null. Step 2. Delete A tends to B from the grammar. Step 3. Repeat from step 1 until all unit productions are removed. Parser. Parser is a compiler that is used to break the data into smaller elements coming from lexical analysis space. A parser takes input in the form of sequence or tokens and produces outputs in the form of a parse tree. Parsing is of two types, top-down parsing and bottom-up parsing. Parsing is divided into two types, that is top-down and bottom-up parsing. Top-down parsing. The top-down parsing is known as recursive parsing or predictive parsing. Bottom-up parsing. Bottom-up parsing is used to construct a parse tree for an input string. In the top-down parsing, the parsing starts from the start symbol and transform it into the input symbol. Parse tree representation of input string A, C, D, B is as follow. Uh, here we can see the tree. A is divided into A, T and B, and now T can be written as R and D, and now R is written as C. So we can form A, C, D, B. Bottom-up parsing. Bottom-up parsing is also known as shift reducing parsing. Bottom-up parsing is used to construct a parse tree for an input string. In the bottom-up parsing, the parsing starts with the input symbol and construct the parse tree up to start symbol by tracing out the rightmost derivations of string in reverse. For example, productions are E tends to T, T tends to T into F, T tends to ID, F tends to T, F tends to ID. Parse tree representation of input string ID into ID is as follows. Here we show here first step id into id. Now f id can be written as uh, f can be written as id, then f into id. Now t can be written in the place of f, then t into id. Now in step 4 t into id, and in step 5 t can be divided into 2, t and f, t into f. Then we can write t tends to t into f, and t tends to f, and f tends to id. Here also f tends to id. And in step 6 e tends to t, and t tends to t into f, and t tends to f, and f tends to id. And here f tends to id. Conclusion. Parse tree is the graphical representation of symbol. The symbol can be terminal or non-terminal. In parsing, the string is derived using the start symbol. The root of the parse tree is the start symbol. It is the graphical representation of symbol that can be terminal or non-terminal. Parse tree follows the precedence of operators. The deepest subtree traverses first, so the operator in the parent node has less precedence over the operator in the subtree. Thank you.